Hey everybody, it's Mrs. Kalinicki. Hope you guys are enjoying your Wednesday. Alright, so we're going to have a pretty fun class today with math. We're going to do some experimenting. Just like the project we had done with the Skittles, this activity is going to involve you actually doing some probability activities. So the first thing you're going to do is everybody is going to get a coin. Okay, so hand those out and pause the video. We'll come right back. If I keep talking, it's all right. No big deal. So everybody should have a coin. And I want you to fill out these two blanks before we start flipping the coin. So leave the coin on your desk. Here we go. The first statement is asking you, there are blank possible results. So what are the possible results from flipping a coin? Well, you can either get heads or you can get tails. So the answer is there are two possible results. Now, before you flip it, I'm going to ask you to make a prediction. Out of 10 flips, you're going to flip the coin 10 times. Out of those 10 times, how many times do you think you will flip heads? How many times do you think you will flip heads? Write down an answer here. And it can be different from the person next to you, but out of 10 times, how many times do you think you're going to flip heads? Okay, so now what you're going to do is within the confines of your desk, don't make the flips crazy and don't go running around the room after a coin. But if you want to spread out a little bit, sit on the floor and that's fine. But stay in the classroom. I want you to flip the coin 10 times. When you do that, every flip I want you to write down your result. So if you flip heads, you're going to write heads. If you flip tails the second time, you're going to write tails, and so on and so forth. And when you hit 10 times, you're done. And you're going to come back, and then we'll do the next activity. Okay? So go flip the coin 10 times, and we're going to come back. Okay, so you flip the coin 10 times. So all of these should be filled out. I'm just going to fill it out based on what I did. Tails, tails, heads, tails, heads. All right, so my prediction was I was predicting about 5 times. So it says, tally your results in the table. How close was your guess? So how many heads did you actually get? So I got 1, 2, 3, 4. So how close was my guess? I would write close. Close, you know, I got 4. I had 4. So it was close. Were you close? Should be pretty close. Maybe 1 or 2 off at most. All right. The next activity is going to involve, so guys can collect the coins. Somebody will go around collecting the coins, put them back in the bag. There they are. The next thing you're going to need is you're going to need a bag of tangrams. And tangrams are actually, it's actually a Chinese puzzle. And it involves different shapes. And then what you can do with the shapes, which is pretty cool, is you can actually put them all together and make one big square out of the shapes by fitting them together kind of like a puzzle piece. So that's pretty cool. But we're not going to do that right now, but I will give you time to do that at another time. But here's my question to you. Take them out of your bag very carefully. Try not to rip the bag. And I want you to take a look at what kind of shapes are in them. And then I want you to answer this question. There are blank possible results. So how many different things can you pick out of this bag? So if you look in the bag, there are 2 large triangles. There are 2 very small triangles. There is a medium triangle. There is 1 square, and there is 1, we talked about this shape, parallelogram. So technically, there are 7 possible things you could get. I would accept 7. If you just saw that there were triangles and a square and a parallelogram, then there would be 3 different results. If you saw that there were 2 of the same kind of shapes, you know, here's 1 kind of shape, here's 2 kinds of shapes, 3, 4, 5, then that could be 5 possible results. But we'll just do the total. And there are 7. Actually, we should change it to 5 because there really are only 5 things that could happen. 5 things that could happen is I could get a big triangle, that's 1. I could get a small triangle, that's 2. I could get a medium triangle, that's 3. Ooh, watch it, almost move my window. I could get a square, that's 4, and I can get a parallelogram, that's 5. So there are technically 5 things that could happen. Alright, so now you're going to, in a few moments, you're going to put the shapes in the bag, shuffle the bag around, and pick out a shape. And you're going to do it 10 times. You're putting the shape back each time. So shake the bag, pull out a shape, see what it is, write it down, put it back in the bag. So the letters that you're going to use in this diagram is you're going to use T for triangle. T for triangle, right? Makes sense. S for square. And P for parallelogram. Okay, I don't really care if it's a big square, or a triangle, or a small triangle, or a medium triangle. If you want to write that down, that's fine. So it's up to you. But so now think about this before you do it. How many times out of 10 do you think you're going to pick that square? It's a little different from the coin because the coin kind of had an even amount of chances to pick a heads and a tails. The square is, there's not that many squares in that bag. So think about your choice. How many times are you going to get a square? Make a prediction. And then pause the video, and everybody individually is going to go and pick their shapes out 10 times. And then come back to the video when you're done. Alright, so hopefully you're back, you're done. You have this whole chart filled out. I'm going to fill it out with mine. I got a triangle, triangle, parallelogram, I got another triangle, I got another triangle, and I got the square, and then I got the rest were my triangles. So I guessed I was going to get the square one time, and I actually guessed it exact. I actually got exactly 1 square. So now if you predicted more squares and you didn't get very many, take a think about why. Why wouldn't you have gotten that many squares? Why were most of mine triangles? Why are probably most of yours triangles? Well, most of ours are triangles because there are just more triangles in the bag. I have a better shot at picking a triangle than I did at picking a square or picking a parallelogram. Now, before we move on to the die, I want you to scroll down. Well, I'm going to scroll down. But I want you to scroll down to the bottom of your paper. It says you roll a die, but I want you to copy down this stuff. I want you to pause the video, copy down this stuff at the bottom of your sheet. Yes, you do have to write the word theoretical, and you do have to write the word experimental. It's only twice, so just make sure you write them down. Pause the video. After you got it copied down, come back and we'll talk about what they mean. Okay, so based on our project that we did with the Skittles, we talked about theoretical and experimental probability. What you just completed up here was the experiment. We completed an experiment to see how many shapes we could get, what shapes we got when we got them. Same thing with the coin. How many times did we get a head? How many times did we get a tails? So look at your results. Here are my results. What was the chance, based on these results, that I got a heads? And you're going to have to do it for yours too, so it's different. My answer and your answer might be different. So I got 4 heads, so I'm going to write on my coin under experimental that I got 4 heads out of, but now this will be the same for everybody. How many times did we do the experiment? We did the experiment 10 times. So everybody's going to have 10 as their denominator, but me, because I got 4 heads, 4 will be my numerator. Okay, so everyone's answer is going to be a little bit different based on how many heads you got. However, if I'm talking about the theoretical probability, meaning a plain coin, based on a plain coin and what I know about a coin, what is my chance of getting a heads on a coin? A single coin flipped 1 time. Well, you should know that it's 1 out of 2, because there are two things to get. I can get a heads or a tails, and there's only 1 heads on my coin, so 1 out of 2. Do you see how these two are different? This one's based on what I know about a coin, and this is based on the experiment that I did. So now I want you to look at your theoretical probabilities. on your tangrams and your experimental probabilities on your tangrams. What you can do is, based on the color of your tangram, there should be 2 of every color. What you could do is work with a partner of your same color to try to fill out these. Again, based on what you have, your experimental will be different from your partner, but your theoretical should be exactly the same. I'll say it one more time. You can work with a partner if Ms. Freifeld and the sub allow you. Try to figure out these 4 probabilities based on your information. So you and your partner's information may be different, or I'm going to say probably will be different for these 2. But your theoretical probabilities based on the bag, based on what you all started out with, what is the probability of getting a square? What is the probability of picking a triangle? Pause the video, try them out, come back. Okay, so according to the bag that I gave you with tangrams in it, there were 7 shapes in each bag. That's it. Now, how many were squares? 1. That's it. Everybody's theoretical probability of picking a square is 1/7. What about a triangle? Well, there were 2 big, 2 small, and 1 medium. So that makes 5 triangles. So my probability of picking a triangle is 5 out of 7. Now, based on your experiment, these answers will be different. However, everybody should have the same denominator. We all did the experiment 10 times. I'm going to go up and look and see what my numbers would be. Based on my experiment, how many times did I get a square? I got the square 1 time. So my numerator is going to be 1. Yours might be 1. Yours might be 0. Yours might be 2. I don't know. How many times did you get the square? And now I'm going to go back up and look and see how many times did I get the triangle? 1, 2, 3, 4, 5, 6, 7. I got the triangle 8 times. Wow. So my triangle probability in an experiment was 8 out of 10 times. All right, so we have to understand the difference between theoretical and experimental. Experimental is based on the experiment that we did or on data that a problem may give us. Theoretical probability is based on the information that is given to us at the beginning. A coin has 2 heads. The tangrams have 7 pieces. 5 of them are triangles. 1 is a square. 1's a parallelogram. All right, so now, again, you may want to work with your partners, or you may pick different partners, or you may want to work independently. There's enough. Either way, Ms. Freifeld or the sub wants to do it. What you're going to do now, take the tangrams back. You're going to roll a dice, or as we call it with 1, a die. That's what 1 dice is called. A dice is a set of 2 dice, but a die is just 1. So you're going to roll a die. Now, after you have 1, take a look at how many sides there are and how many possible results are there. There should be, on everyone's die, there should be how many different sides. Pause it if you're not ready. Okay, there should be 6 different sides. There should be a 1, a 2, a 3, a 4, a 5, and a 6. Now, I want you to make a prediction. Out of 10 rolls, because we're going to do that in a second, out of 10 rolls, how many times do you think you will roll a 6? How many times do you think you will roll a 6? Make a prediction. And then we're going to flip our page over, and you're going to take a moment, and we're going to roll the die 6 times. Again, while you're rolling, make sure you're writing down each time. So the first time I roll, I'm going to get a 3. The second time I roll, I'm going to get a 2. And I'm going to keep going and rolling until I'm done. All right, pause the video, come back when you're done. All right, so if you're done, I just about finished. I'm going to write down my final numbers here. There we go. All right, so my guess was I was going to get a 6 like 1 time, maybe 2. And I ended up getting a 6 2 times. So how close was my guess? Pretty close. I actually got it 2 times. My guess 1. Okay, not bad. So let's take a look at these. Let's take a look at these questions. But I actually want to add some questions onto the second set of questions. So let's scroll down here. here are our questions. I want you to pause the video and I want you to copy down these questions right here because we're going to talk about the dice a little bit more. Again, using the terms experimental and theoretical. Okay, once you have them copied down, I want you to think about them. Try to do these by yourself. The experimental is based on the experiment you did. So look at what you have in your chart. I want you to tell me what is the probability of picking an even number based on your information, based on your table. What was my probability of picking an even number based on these numbers that I got? Then I want you to think about what's the probability of getting a number, yes, that means number greater than 4. How many of these were greater than 4 based on my experiment? Then, based on what you know about a die, what is the probability of picking an even number? Based on what you know about a die, what is the probability of picking a number greater than 6? Pause the video. Give it a try. Actually, before that, let me pause you. Let me pause myself for a second. I want you to flip to page, I think it's page 2 in your notes, page 3 in your notes. It's the homework page. And on the other side of it is a note sheet. And I want to write down some stuff because this question is bringing up something to write down. And even though you probably know it, I just want to write it down anyway, just so that way you have it in case you need it. In this one box, we're going to start off with even and odd. That's it. I want you to know what are the difference between even and odd. So if you want to share, you can share. What are some even numbers? I bet you're going to start with 2, right? 2, 4, 6, 8, ... In case you need to know, 0 is actually an even number, so you may want to add 0 to your number. What about odd numbers? Odd numbers are kind of like the opposite. So if it's not even, it's got to be odd. So what are my odd numbers? 1, 3, 5, 7, 9, ... Okay, make sure you have those written down before we go back, because now I want you to ask you, what's the probability of picking an even number? And now you know what some of the even numbers are. Okay, pause it if you need to, but I'm moving on. Okay, here we go. All right, so now that you know what even numbers are, based on your experiment, I want you to write down the 2 probabilities. And then take a moment and say, okay, now based on what I know about a dice or a die, what is the regular probability of picking an even number? What's the regular probability of picking a number greater than 4? Pause the video, come back when you're ready to go over it. Okay, here we go. Now, these will be different based on my experiment, based on your experiment, but our denominators will be the same. Everybody did the experiment 10 times. So I'm going to look at my numbers and see what's the probability of picking an even number. Based on what's here, I'm going to kind of do a little check on my even numbers. Here's my even number, and that's it. So I have 4 even numbers. So my probability would be 4 out of 10. Yours might be 6 out of 10, 5 out of 10, 8 out of 10. I don't know. Depends on what your even numbers were. So hopefully the teachers walked around to make sure that they checked that. A number greater than 4. So is 3 greater than 4? No. 2? No. 5? Yes. 3? No. 6? Yes. 6? Yes. 4? Is 4 greater than 4? No. So be careful. 3 is not, and 1 is not. So the number of responses that I got that were greater than 4, there were 3 of them. So my probability is 3 out of 6. Again, yours might be different depending on how many numbers bigger than 4 you got. Remember, that's only 5 and 6. So how many 5s or 6s did you get total? All right, so now just based on what you know about a dice. You know a dice is 6-sided. It's got the numbers 1, 2, 3, 4, 5, and 6 on it. How many of those are even? 1, 2, 3. There's 3, but out of, this time, only out of 6. because a dice only has 6 sides. Now, how many of these is greater than 4? Again, we talked about that. 5 and 6 are greater than 4. So my probability is going to be 2 out of 6. These two need to be exactly the same as what I have on here, because these are true no matter what dice you have. It's a 6-sided dice that has numbers 1 through 6. Final thing I want you to do, we're going to answer these questions. Do you have a better chance of getting heads or tails? Well, that's kind of a trick question. You actually have an equal chance. So I'm going to type it, and I want you to write the full sentence. You have an equal chance at both. Because you do. There's no, you can't get a better chance of getting a heads or a tails because the coin is fair. It's a fair coin. Okay, now this is about the tangrams. What shape should you expect to pick the most of? So out of that bag of shapes, what should you predict that you should get the most of? We have an answer? What shape was the most in that bag? You should predict that you should probably get a triangle. And why? Because we'll say 5 out of 7 shapes were triangles. That's why. I'm expecting a lot of triangles because most of my shapes were triangles. Most of my shapes were triangles. All right, copy it down. Pause if you need to. My final question is, do you have a better chance of picking an even number or the numbers 3 or 5 on a die? Now, before I answer that question, I want you to think about, well, what are my even numbers? So my even numbers, which we just talked about, are on a die, right? Remember, here's my die. On a die, the even numbers are 2, 4, and 6. And then my numbers, these are just 3 or 5. So what do I have a better shot at getting? Getting these numbers or getting these numbers? What's my better chance? What's the better chance of getting to it? It's a better shot at getting these 2 numbers, better shot at getting these 3 numbers. Well, you should answer that you get a better shot, better chance of getting even numbers because there are more even numbers. There are more. We'll just say there are more. There's just more of them. Out of 6 chances, I get a 3 out of 6 chance of picking one of these numbers instead of a 2 out of 6 chance. So it's really not, it's not better. This is a 3 out of 6 chance. This is only a 2 out of 6 chance. So obviously my chance is better here. It's a higher fraction. And then my final questions for you involve picking one of you to come up to the board. We know we like to do that. We do that a lot here. So if you need to pause the video, that's fine. Copy it down. If not, let's keep it playing. So if I'm going to choose one student from our class to come up and do the board, let's just assume, because I don't know, if everybody's there today. So let's assume everybody's here. Hopefully you're all there. How many possible outcomes are there? How many students are there that could possibly come up to the board if everybody was there today? How many are there? There are 8. There's 8 of you. The event. Now, this is a word that we use in probability. What is the event? The event is something that I'm doing. So one of your events that you did today was rolling a die. Another event you did was flipping a coin. Another event that you did today was choosing a tangram. So what is the event that's happening here? What am I actually doing? Well, what I'm doing, hopefully you're writing it, is I'm choosing a student. That's the event. That's what's happening. Now, think about this. In this classroom, and again, based on everybody being here, I want you to think about, I want you to copy this down. When I write this, and you're going to see this notation a lot when we do the next couple of lessons, the P stands for probability. So this is really saying is what is the probability that I pick a girl? Because it's based on this situation that we just talked about. So choosing a student from our class. What is the probability that I pick a girl? And this is a question. And did you hear all those words I put in there? but the words P and girl are the only ones on my paper. So when you read this in class, I don't want you to say P girl. I want you to say, what is the probability of picking a girl? Okay, so now what is the probability of picking a girl? How many girls do we have in our class? We have, how many? We have 6. Out of how many total students? 8. Okay, so it's a 6 out of 8 chance of picking a girl. But now same thing. Do not read this as P, not a girl. I want you to read this as, what is the probability of not choosing a girl? Okay, so what's that probability? The probability of not choosing a girl. Well, how many boys are there then? What's the opposite? 2 out of 8. Take a look at these two, because we're going to talk about this tomorrow. Of event happening and event not happening. These should, and they always will, if you have the probability of something happening and the probability of something not happening, it should add up to 1 whole. And I want you to write that down. Should total 1 whole. Okay, we're going to talk more about that tomorrow in my video tomorrow, but for right now, hope you had fun today. Hope this kind of got you a little excited about probability. We're going to talk more about probability tomorrow. Make sure you clean up, and thank the sub and thank Ms. Freifeld for helping you guys out today, and I will see you tomorrow on another video. Take care, guys. Bye. Don't tell me I did the whole video. I didn't do it.